Good afternoon and welcome to Mr. Michelbarro's Maths World. This is the way it is. Now we're talking about exponential functions. This is the last one in the series today we are focusing on reflections. So if I've got a basic exponential function here, let's call it y, or I'm actually calling it an equation now, 3 to the power of x. I can reflect it around the x-axis, as in here, or around the y-axis, like so. And how you know what's going on is by the signs in the equation. So this one could very well be y equals 3 to the negative x. Okay, now that makes sense because if x is very large and very negative, down here, it's going to be 3 to the power of a negative, therefore a positive. So it's going to start off very positive, and the larger x gets, over here in the positive direction, you're going to have a negative positive, and we know that that is going to be a very small number, so it's tending to 0. Now you can apply a similar sort of logic, I suppose, to these ones down here. This one's going to be y equaling, think of it this way, whereas our equation is always positive in this one it's always negative. So the way to achieve that is to put a negative sign in front of the base in this case. Okay, but that would be positive, the x would be positive, and you can experiment with that at your own leisure. Now this one is a combination of both. It's being rotated around the x-axis and then rotated around the y-axis. So it kind of stands to reason that this could be a possible equation for that plot. So I'd recommend that you memorise those 4 plots because they make the plotting of the graphs very easy. The most important thing, I think, when plotting something as messy as that is to understand what shape it is going to be. Okay, now whilst we're on that subject, let's turn our attention to this one here. We've got a negative 2 there, times, and everything around here seems positive. And then you've got a shift downwards of 1. The plus 1 there is indicating we're going to shift it to the left a bit by 1 unit, but I'm not focusing too much on that at the moment. The important thing for me to do is sort out in my head which of the 4 shapes I'm going to be interested in. So it's negative there, positive all around there. I'm interested in this basic shape here. Okay, so with that knowledge in mind, I will go and plot it. Also, I'm going to find the intercepts, the asymptote, and we're going to state the domain and range. Okay, so here we go. Now, as I said, it's that basic shape there. Let's see how I move it, the basic one around the number plane. Let's plot a few values, in fact. It might be convenient to let x equal 0. It's going to give me the y-intercept, one of the things I had to find anyway. So letting x equal 0, my function is going to equal negative 2 times 3 to the power of 1, isn't it? Minus 1. So that's going to equal negative 6 minus 1, negative 7. So I have a y-intercept, let's note that down, of an intercept at 0, negative 7. What's another convenient value? Well, how about, anything will do. I've substituted the 0 in. What about 1? So when I substitute 1 for x, I get negative 2 times, it's going to be 9, minus 1 equals negative 18, so negative 19. So 1, negative 19 is going to be another shape, another plot point. Now, what about the, can I find an x-intercept? Is it going to have an x-intercept? Seemingly not. And the reason is because we've already decided the shapes like that, but what we want to do is shift it down one, don't we? And what we notice is that as x gets very, very large, certainly that's going to get very large. That's going to turn it into a very large negative, a negative times a very large will be very large or negative, minus 1. So that confirms that it's tailing off down there. But what about when x gets extremely negative? What have we got? Well, that's going to be negative, plus 1, still very negative. So minus 2 times a very, very small number. In fact, so small it's going to approach 0. Okay? But then I'm going to take off 1. So it seems to me that there's going to be an asymptote where the function is equal to negative 1. Okay? Now we put our asymptote in the usual way, a dotted line, like so. Excuse me, I've got a couple of points to substitute in. This isn't really to scale, but it doesn't matter. 0, negative 7, so plot point there. And 1, negative 19 gives me a bit of another point for reference. Well, that's way down here. So it's very much not to scale. Like so. So, remember the shape? So it's going to look like this. It's approaching the asymptote, of course, and it's going to go sharply down like, sorry, that's misdrawn, that's y-intercept, so down like so. And my line didn't line up too well there, but you get the idea. Okay, now of course we have to label everything, including the graph. That's a very poor line, but I think you get the general picture. Okay, we indicate 1 there, negative 19 here. And that's how we do a graph for those more complicated ones. Now we haven't stated the domain, we need to do that. The domain, remember what the domain is? It is the set of all possible x values our function can take on. And with these exponentials, there is no x value that is out of the question. So it can be anything from negative infinity, but not including of course, to infinity. The range, however, well, that's easy to tell from our sketch. Our range can take on any value less than negative 1. Okay? So you're always looking at the fx axis, or the y-axis, to sort out what your range is. And it can be anything from negative 1, can't be negative 1 itself because that's an asymptote, down to negative infinity. So we write that in this way. The function will always be less than negative 1. And that's how we do those, plot those functions. I haven't focused too much on the shifting, but really you've got the basic shape and it's and there's a dilation going on as well. But we don't need that for these sort of graphs. Okay? So we might leave it there.